Alright, we're all set. Alright, finally get to finish the first section of the book. 1-1, day 3. Domain. Domain and range. This never wants to go away, does it? So if you have a graph, what do we look at to see domain? Do you remember? Adam? The x values. How far left does it reach and how far to the right? Domain's left to right. But we call it the set of all x values. So think left to right. And then the range is the set of all y values. So think how low to how high. Low to high. And we also want to be able to determine if an equation is a function. Do you remember the test you used to test to see if it was a function?
Vertical line test.
Vertical line test. And how did that work again? Do you remember how it worked?
If there's more than one point that goes through the vertical line, it means it's not a function.
Correct. Because every x value can only give one y value. And if you draw a vertical line, and I'll draw it in a minute, you'll have one x value that's giving out two different y values, not consistent there. So that makes it not a function. So a vertical line test determines if a relation is a function. So what has to happen is any vertical line can intersect the graph only once, only one time. I don't know if I said that very well. Only one time to be a function. Here are pictures worth 1,000 words. So, if I had a relation that looked like this, would that be a function? Adam, why not?
Because if you draw a vertical line, kind of like where it swoops.
Yep.
It's gonna have two.
It's going to have at least two. Looks like even more than two. So you can find a spot where a vertical line, in this case, hits 1, 2, 3 times. So this one x value is giving out 3 different y values, which makes it not a function. So you're looking for any one spot you could possibly draw a vertical line that hits it more than once. Makes it not a function. Okay, so our next set of examples is just going to be given a graph or given a relation, decide if it's a function, and give domain and range. Can I get rid of this? is it a function? And then give domain and range. So here's my relation. It's a nice ellipse from your favorite chapter in advanced algebra. Football looking, appropriate for today. I was trying to hit 3 there. It doesn't really go above 3, even though this was supposed to max out right there at 3. That's the point of that. I didn't do a very good job, but I think you get it. Okay, first question. Is it a function? I'm going with Alex. Is it a function? Nope. But it does have a domain and range. So domain, and we're going to write our sets of numbers with that little condensed interval notation with the squared brackets and the rounded brackets, because that's the shortest way to do it. So domain, we want to go left to right, and we want x values. So if I look, this is my leftmost point. What is its x value? Adam. So I'm going to start at -2. Is -2 included? Does it pass through -2? So what kind of bracket do I want? That little squared one. Okay? So that's our leftmost point. Now we go to the rightmost point. And domain is the x value there. Now, 1, 2, 4. And does it pass through 4? So we want it squared. Okay, range. Range is low to high. So find your lowest point on the graph. Lowest point is right here. And range is y values, or I should say our y values. What's the y value for this point? 0. Does it pass through it? So I put a squared bracket or I put rounded bracket? Squared. Now I'll find your highest point. Range is low to high. Here's my highest point. And range is the y part of that ordered pair, not the x. The y part is 3. Left to right, low to high. Left to right x's, low to high y. We're going to call that one A because we're going to continue on in here. B. Go with a nice parabola. I'm listening to his conversation over there. All right, function first. Let's go, Emma Wyman. Function or not a function? Yes, a function. Passes the vertical line test. Domain. Now remember what these arrows mean. What's going to happen to this parabola as we continue out on the x-axis, Adam? Which way? Up. Is that all it's going to do is go up? What about width? It's going to get wider, it's going to stay?
It should go.
Wider, taller, wider, taller, wider. That's what the parabola's going to do. Keep growing. So, remember, domain is left to right. This branch, even though it's going to keep going up, it's going to keep going left. How far left is this branch going to go as it goes up? Negative infinity. It's going to be really high, high, but it's going to be really wide, wide. So on the x-axis, it's going to be negative infinity. And this branch here, it's going to get higher, but it's also going to get wider to the right. And how far to the right am I going to go? Positive infinity. Remember, infinities are always rounded bracket. Now range. Low to high. So you find your lowest point. Lowest point is here. Because I'm talking range, I want the y value there. What is the y value of that point? Elijah? 2. Oh. And is it included or not included? Included. I gotta fix that. Squared. And now for high, well, I've got 2 points that are going high. Doesn't matter which one. How high is this thing going to get? Infinity. So it's going up to infinity. And that's always rounded. Okay. What happens if I give you the relation as an expression? And then I ask you, is that a function? What's its domain and what's its range? Okay, you're probably thinking A and B were pretty easy. Yeah, I get that. Now I don't have a picture. Now it's not so easy. A couple things you can do. Jimmer, what do you think?
Solve for y.
Solve for y. That's a perfect thing to do. So let's get it y equals, because that's usually the way we see our expressions. So we're going to kick the x over by subtracting. 2y equals 10 minus x. Divide by 2. We're going to divide everything by 2. So that's 5 minus 1/2 x, or x divided by 2, however you want to write that. I'll leave it as x divided by 2. Okay, now that we've got it y equals, what do we do? Adam? You can graph it on your graphing calculator, or you can take yourself back to advanced algebra where you learned when you had exponents and when blah, blah, blah. What is this going to look like when we graph it? Because the x is to the first power and the y is to the first power? Yeah, it's you, sorry.
Linear.
It's a linear function. It's going to be a line. So, if you didn't know that, it's okay because you got a nice little handy-dandy grapher there that'll help you out. So if you want to graph it, go ahead, y equals. Otherwise, you can see the y-intercept and I can see the slope and I can hand graph it. It's up to you where you're at with what you remember there. I'm just going to graph it. So this 5 is giving me the y-intercept. Slope is a negative 1/2. So that means down 1, right 2 to find another point. And linear functions continue. So now we can ask the question, is it a function? Lexi, is it a function? Yes, function. Domain. Left to right. This arrow, even though it's going to keep getting higher, is going to keep taking me to the left and higher, left and higher, left. How far left am I going to go? Even though I'm going to be way up in the air, how far left am I? Negative infinity. Now right. This is the arrow that's going to take me to the right, but it's also going to take me down. I don't care about the down, but how far to the right am I going to go? Down or right, down or right, down or right. How far to the right am I going? Infinity. Range. Low to high. This is the arrow that's going to take me low. How low am I going to go? Negative infinity. And how high? Infinity. Linear functions always have domain and range infinities to infinities. Never going to be different because they go forever. Doesn't matter. Oh, so horizontal, not quite. Range is only one number. It's got to be at an angle. That one. Here we are. X equals y squared plus 2. Any idea what that's going to look like when we graph it? Don't know how much time you spent on these last year. If these were flipped around, if the x was squared and the y was just to the first, what would I have? Parabola. Y equals, so you have an x squared term, it's a parabola. Well, this is a parabola too. Jimmer?
It's a sideways parabola.
Sideways parabola. So you did talk about them a little bit last year. Okay, again, if you didn't remember that, well, it's okay because we got a handy dandy grapher. We're going to solve it for y, get it y equals, and then graph it and see what we get. So we're going to get y equals, so I'm going to subtract 2. Now what to get it y equals? Square root. Let's graph that. Jimmer told us what we should be seeing, a sideways parabola. If you need a calculator, come on up and grab one. They're back here. Is that a sideways parabola? No, half of one. Why didn't we get the whole sideways parabola? Where did we go wrong in this algebra? It's not that we went wrong, we forgot something, yes.
It's that you can't take the square root of a negative number.
Nope.
Plus or minus.
It's plus or minus. Remember, when you take the square root, like if I had y squared equals 25, so I've got y squared equals something, and I'm do the square roots, remember I'm asking what numbers squared give us 25 when we introduce the square root in the problem, because there wasn't one to start with, but here I put one in. We've got to remember plus and minus. So now, in order for us to graph that in the calculator, it's got to go in two separate equations. It can't do plus minus in one thing. It can only do one thing at a time. So what we're going to do is go back to the y equals. We've got the positive square root in. We'll go down to y2 and put in the negative square root of x minus 2. So the first one's the positive one, the second one's the negative one, and now when we graph, we get the bottom half. Now together they make that sideways parabola. Vertex at 2. So again, as this thing keeps going, it's going to get farther apart, so higher, lower, and farther out, farther out, farther out. So first question, is it a function? Allison? Does it pass or fail the vertical line test? It is not, because when I draw this vertical line, it hits twice. That fails the vertical line test. So it is not a function. Domain, left to right. So find your left point. What part of that point gives us the domain? Let's go Sid. 2. It is included. And now right. Both of these arrows are going to go to the right as they get taller and lower, but how far out to the right are they going to go? Infinity. Range. Low to high. Well, the low is this arrow. The high is this arrow, so it's going to keep opening. So what's my range going to be? Negative infinity, positive infinity. So if you're on the arrows, you've got infinities. Negative infinity, positive infinity. And then one more, just to clear something up. Y equals the square root of x plus 1. What's that going to look like when we graph it? Adam? Half a parabola. So the difference between E and D is that D didn't have a square root. I introduced it when I was solving for y. Here, this is just saying I only want the positive square root of x plus 1, not plus and minus. It's here given to me only the positive. So it's going to be that half of a parabola that we saw when we first graphed. So square root x plus 1 and if you don't have a graphing calculator, there's tons of them online to make graphs. You got phones, so no excuses. You don't need the actual calculator to graph a function. So it is a half a parabola. So is that a function? Trent, does it pass the vertical line test? Yes, it does. Domain. How about Chloe? What do you think for the leftmost point for domain? -1. And the right value? How far to the right is it going to go? Infinity. I'm on an arrow. Arrows are infinities. Range. Low to high. Caden. 0. 2. Perfect. Square there, rounded there. Okay. Last part, I think. Yeah. Okay, finding domain from 2 special rules, and domain only. First of all, when you take the square root of a number, Jimmer said it earlier, we can't take square roots of negative numbers, because that's asking what number times itself gives me a negative number. Well, no real numbers do that, imaginary ones. So, if you have this, the values under the square root have to be greater than or equal to 0. So we can take the square root of 0, and we can take the square root of positive numbers. Can't take the square root of negatives. And the other thing we can't do in math what number in the denominator gives us an undefined value on our calculator when we type it in? Jimmer?
0.
0. The value of the denominator cannot equal 0. Okay. Use the special rules to find the domain. Alright, so again, if I just asked you to find the domain of these functions and you saw this one, you wouldn't even know that the special rules apply. You're not going to know to use the special rules until you see something funny happening on your calculator. What's going on here? Let's graph it and see what's going on, what it's going to look like that says, oh, I probably need to look at those special rules to find my domain. So if we go to y equals 1 divided by, and for me, I've got to put that denominator in parentheses because my calculator doesn't make it look like a regular fraction. X minus 2. If you're like mine, you just type in 1 divided by x minus 2 without the parentheses, it's only going to do 1 divided by x, and then subtract 2 from that. That's not quite what we want. Graph. Okay, looks a little ugly. Not everybody's calculator is going to look like that. But I see something funny happening in the middle there. What is happening in the middle there? Yeah. A vertical asymptote. Okay. Mine draws it in because it's older technology. It's kind of connecting the points even though there's nothing there. The newer ones, the operating systems, I think you just see nothing there, correct? So it all depends on what kind of calculators you have. So the graph does have that vertical asymptote. Looks like it's at 2. That's our imaginary line that the graph approaches but never touches. So the graph itself looks like it has 2 branches to it. Looks like it approaches the x-axis and that vertical asymptote. And then it has a branch up here. So all I'm asking for is domain. Domain's left to right. Well, if I look, my leftmost point is going to be on this branch here. And it's on an arrow. That's just going to keep going to the left, to the left, to the left. That's negative infinity. To the right. Well, here's my right branch. To the right, to the right, to the right. That's an arrow. That's infinity. So what I'm saying, if I write this down, though, I'm saying the domain is every value from negative infinity to positive infinity. Is that correct? No, because we got this special thing happening in the middle here. It's our rule 2, where the denominator, you cannot have values that make that denominator equal 0. Well, what value makes that equal 0? The 2. So we have to eliminate, so negative infinity to positive infinity, but x does not equal 2. So we throw that one number out. Or the book, there's a couple ways. They'll do it in 2 chunks. They'll say negative infinity to 2, but because 2 is not included, they'll put a rounded bracket. That's this arm of the graph. And they'll put the little union symbol, because it means including or in addition to. This branch starts at, well, just beyond 2, so that's why it's rounded, and then goes to infinity. Both of these say the same thing. Whichever one your brain wraps around, that's the one you go with. All right, last one, yay. B. X plus 2. X plus 2. X minus 1. So if we graph this, when you type it in your calculator, you will need an extra set of parentheses around this denominator. Graph that. Looks a whole lot like the one I had, except it's over at 1 for our vertical asymptote. So, it appears, by just looking at the calculator, that we've got a vertical asymptote at 1. But because of our special rule that we had there, the denominator, what else is going to make the denominator 0 besides putting a 1 here? Because 1 minus 1 is 0, 0 times anything giving me the 0. That's that vertical asymptote. What about, is there anything that's going to make this equal 0? Negative 2. Press trace on your calculator. It's in the top row. Trace. Trace. And hit negative 2. And then enter. What does it say the y value is? It doesn't have one, because it shouldn't have one, because we would be dividing by 0. There is no value. What's happening there that's not showing up on our calculator? There's a hole in the graph. It's called a removable discontinuity, back from, again, advanced algebra. It's removable because it's got the same factor in the numerator and denominator. That's called a removable discontinuity, where this one stays. If it's non-removable, it's an asymptote. If it's removable, it's a hole. So at negative 2, we will have a hole in the graph. I don't hit you with a lot of that on the test at all. I don't even think I addressed it. Just so you know. So don't feel too bad about those if you're like, oh my god, that was a lot. This stuff's a little, I don't know, not super important, but it is there, it exists, so that's why we cover it. But our domain then, anyway, we still should be able to, given a picture, give the domain. Again, 2 ways to do it. Left to right. I see negative infinity to positive infinity, except we've got 2 values that are discontinuous. The whole, so x doesn't equal negative 2, and x doesn't equal 1. So we throw out the discontinuities, or we would have to do it in 3 chunks with the interval symbol. So it would be this first chunk, which would be negative infinity to negative 2 with a rounded bracket at negative 2, in union with the next chunk starts at the negative 2 and goes to 1. Again, rounded, and then in union with the third chunk, 1 to infinity. Just so you see this stuff, because I think you will see stuff like that on that SAT where they use that union symbol. So that's why I just like to cover all the bases. All right, we got there. Assignment, page 13, 36, 44, there's a couple review problems, and then 75 to 91. All that is domain, range, tell me if it's a function. They're pretty quick and easy.